Welcome back to The Explainer. I'm absolutely thrilled you're tuning in today because we are tackling something truly massive. Have you ever stopped to think about the human population, not just as, a giant crowd of people, but as a dynamic, breathing ecosystem? Because that's exactly what it is. It's this incredible, living system that is constantly shifting, growing, and transforming right before our eyes. And the absolute coolest part? We can actually measure it. We can literally decode the hidden rhythms of human life.
But of course, that begs a pretty massive question. How exactly do we measure the story of humanity? How on earth do we capture all that sheer complexity, the births, the deaths, the constant movement of people across borders and cities, and turn all of that into data that actually makes sense? Well, that is exactly where our topic for today comes in. We're diving deep into the fascinating science of demography.
Okay, let's dive into this. Here's our roadmap for today. We'll start with defining the human population, then the mechanics of population change. Next, characteristics and impact, and finally, we'll wrap up with the father of demography.
Section 1. Defining the human population. The scholarly foundations of how we count ourselves.
To truly understand the world and all its shifting patterns, we first need to arm ourselves with the foundational tools laid out by scholars. Back in 1985, Roland Prasad stated that demography is the study of human populations in relation to the changes brought about by the interplay of births, deaths, and migration. I just love that word, interplay. It perfectly highlights that these factors aren't happening in isolation. The way births, deaths, and movements interact, that's quite literally the heartbeat of human geography.
Building on that, Prasad gives us this brilliantly precise definition of what a population actually is. In a restricted sense, it's any group being studied where its size and structure depend on persons entering and leaving. So, the really crucial takeaway here is that a population is never just a static snapshot. Not at all. It's more like a flowing river of people. You've got individuals constantly entering the stream through birth or immigration, and others leaving it through death or emigration.
Another prominent scholar, Donald Bogue, alongside similar views from Hauser and Duncan around 1969, expanded on this idea. He defined demography as the statistical and mathematical study of the size, composition, and spatial distribution of human populations. Now, I know spatial distribution sounds like some heavy academic jargon, but it's actually pretty straightforward. It simply means, where are people located and why? Why do millions of us cluster tightly in a coastal city while maybe only a few thousand live in a huge rural valley? Demography is the tool that answers the where and the why.
Now, what's really interesting about this next part is how we measure it. Section 2, Mechanics of Population Change, the 5 core processes and 3 major components.
Shifting from those macro definitions into the churning mechanics of human movement, we're looking at the actual engine of population change here. According to Bogue, there are 5 continuous processes altering a population: fertility, mortality, marriage, migration, and social mobility. But notice how these 5 descriptive processes overlap heavily with the 3 major physical components that numerically alter a population size. Those 3 major components are the birth rate, the death rate, and migration. Those are the 3 primary levers that physically add or subtract human bodies from any given space.
And when we talk about births, we really have to be mathematically precise. There is a very distinct difference between natality and fertility. Natality, or the crude birth rate, is basically a broad brush. It's calculated per 1,000 people in the general population. Fertility, on the other hand, is much more specific. It's calculated per 1,000 women specifically of childbearing age, which is defined here as ages 15 to 49. It is absolutely vital to know exactly which metric you're looking at when you're analyzing this data.
Then we have social mobility, which I find totally fascinating. It's all about changing your status or position in life. For example, if a farmer goes back to school and becomes a professor, that's upward social mobility. Or, if someone goes from being single to being married, that is a fundamental change of their demographic status. And these aren't just personal, isolated life events. When you aggregate them, they literally reshape the entire demographic profile of a society.
Section 3. Characteristics and real-world impact. Applying the numbers to the real world. Because all these abstract mechanics we just talked about, fertility rates, mobility, spatial distribution, they definitely don't just live in a textbook. They have intense real-world consequences that shape the destiny of entire nations. Think of demographic variables almost like character stats in an RPG video game. Variables like education, income, occupation, family relationships, and immigrant or refugee status.
They define exactly what a population is like in a given place. They reveal the strengths, the vulnerabilities, and the true economic potential of a community.
And this next point brilliantly illustrates what happens when government policies collide with those variables. A powerful demographic determinant is a trait or preference that drives massive population change. For instance, think about China's historical one-child policy, combined with a cultural preference for boys. That specific, powerful preference acted as a massive demographic determinant. It artificially skewed the gender structure and fundamentally altered the country's entire population trajectory for generations.
Let's look at another tangible consequence of demographic determinants and rapid growth. According to data from the Bangladesh Bureau of Statistics, in 2011, the population of Bangladesh was 144 million. By 2022, just over a decade later, it had surged to 165 million. I mean, wow, that is a massive addition of human life in a very, very concentrated geographic space.
So what does that kind of explosive rapid change actually mean for us? Well, a lack of family planning leads to rapid population shifts that directly impact massive global issues. We are talking about severely increased pressures driving climate change and global warming. But it's not exclusively negative. It also creates what experts call population asset challenges and opportunities. A massive young population can be an incredible economic engine if they're properly educated, or it can be a huge challenge if resources are scarce.
Section 4, the father of demography, the cloth seller who started it all. Now we're going to shift gears dramatically. We've talked a lot about modern crises and complex math, but I want to introduce you to the remarkably unlikely hero who actually invented this entire science. Let's walk through the timeline of a man named John Grant. Born in 1620, Grant wasn't some prestigious academic. He wasn't a university scholar at all. He was just a humble 17th century London cloth seller. Yet looking at the data of Londoners born between 1628 and 1662, he noticed patterns that absolutely no one else saw. This ultimately led him to publish a groundbreaking work in 1662 called Natural and Political Observations.
It's amazing when you look at his handwritten notes, because Grant's knowledge of simple shop arithmetic, literally just the basic, everyday math he used to sell his cloth, became the foundation for studying human births and deaths. He practically birthed the entire concept of business demography, proving once and for all that you don't need to be a formally trained mathematician to recognize the vital importance of using statistical tables to present data. Using that everyday shop arithmetic, Grant analyzed the census-like data of his time, and he discovered something fascinating. Out of a London population comprising roughly 384,000 people, there were exactly 199,000 males and 185,000 females. He proved with hard, undeniable numbers that slightly more males than females were being born during that period. He was literally finding mathematical order in the absolute chaos of a teeming 17th century city. Let's move along and see how this builds into something even greater. Grant pulled his source data from the Bills of Mortality in London, but his natural and political observations didn't just count bodies. He took it a step further. He cross-referenced government, religion, trade, diseases, and even the air, which was the 17th century spelling for air or climate. Because of this incredibly comprehensive approach, his 1662 publication is now universally considered the absolute basebook of demography. And here is his absolute crowning achievement. From those Bills of Mortality, John Grant created the world's very first life table. He presented mortality in terms of survivorship, successfully calculating life expectancy for the first time in human history. The wild irony of all this, he never actually used the word demography himself, but by presenting data in his own unique, methodical way, he was undeniably the first to do so, rightfully earning him the title, the father of demography. Which brings us to the end of our explainer today, and leaves us with a truly inspiring thought. Think about it. If a 17th century cloth seller could literally invent the first life table using nothing but basic shop arithmetic and some public death records, imagine what we can do today. With the massive computational power and incredible global data at our fingertips, what hidden patterns can we discover right now to solve tomorrow's immense climate and population challenges? The data of us is out there, just waiting to be decoded. Thanks so much for watching, keep questioning the world around you, and I'll see you in the next explainer.